Hello, my name is Nick Drew, and this will be my presentation for ENG Assignment 2A. This is for the Water Surface Quality Modeling course, and this is only a midterm hand-in presentation, so I will be talking about the outline and the research and where I will be focusing on for this project. To begin, this project focuses on understanding the biochemical oxygen demand, the BOD levels, and the Mangapu stream at Otoronga. Using the stellar models as recommended in the project brief, the primary goal of the project is to determine the level of treatment required and to support urbanization in the area. Currently, the stream is not used as drinking water sources, but this research aims to assess what level of treatment will be necessary to make that water, the water that we actually see, a safe water for human consumption. Throughout the presentation, I will be walking you through the key steps and the layout of the project. Biochemical oxygen demand is a key indicator of water quality, as it reflects the amount of oxygen needed for microorganisms to break down the organic matter in the water. High BOD levels indicate high pollution levels, as excessive organic materials consumes oxygen that aquatic life depends on. Understanding BOD is critical for this study, as it directly influences the water quality in Mangapu Stream. It also forms the basis for one of the key indicators used in this research, E. coli, which reflects potential fecal contamination and will be used in the BOD calculation. BOD source typically includes wastewater, agricultural runoffs, and stormwater, especially relevant in the lowlands area like the Otaurahanga. So reflecting off these informations and details, I will be using Stellar Architect to calculate the necessary levels and will be reflecting these informations into the recommendations later on in the project. The primary area of focus in this project is the Mangapu Stream, which connects to the Otaurahanga region, and the stream originates in the hills southwest of Te Kuiti and flows onwards or northwards into the Waipa River. As illustrated in the map provided, you can see both the flow and the stream and the specific data collection points used in the study. The site was selected due to the notable decline in water quality over the recent years and increasing frequency of the flood. It has a well-known tourist attraction point like the Waitomo Cave and the long-standing development of the surrounding towns. The stream still ranks, though, in the bottom 25% of the 20% quartile in the water quality across New Zealand. This highlights a serious pollution issue, one that not only exists today, but also signs of worsening without intervention in the future. In addressing the pollution in the Mangapu Stream, my mitigation strategy will focus on two key biological treatment systems: suspended growth and detached growth. Suspended growth systems, shown on the left side, use microorganisms that float freely in the wastewater. Now, microbial growth helps break down the pollutants effectively and remove the suspended solids. Common systems include activated sludge and sequencing batch reactors. Attached growth systems, however, on the other hand, take a different approach here. Microorganisms can grow on surface or solid surfaces and form something we call biofilms. And these biofilms help the microbes stay anchored on and more resilient as they treat the water. Examples of these systems include trickling filters and rotating biological contactors. I will be focusing on these two methods, or these two types of method, to identify possible mitigation strategies for the project. Stellar Architect will be my primary tool for modeling and calculations. To begin, I will identify the key biochemical contaminants present in the water and that needs to be addressed. Each of these will be assessed against their acceptable limits and control thresholds necessary for safe urbanization of the water used. Using this data I gathered, I will use the Stellar to visualize with graph and tables and simulate the treatment. Steps required to manage these biochemicals effectively will be all visualized on the Stellar Architect. The ultimate goal of this is to either stabilize the water quality to an acceptable level for contact recreation or take initial steps towards long-term urbanization of the water in the area. Towards the conclusion of my project, I will present a set of realistic and practical recommendations. While this may extend slightly beyond the core of the project, the course, I believe it is a very important feature for a future engineer. It is to evaluate whether the project remains feasible and effective in the real-world conditions. I have identified some key considerations, such as the land infrastructure and the key specific site characteristics necessary for the plants. What will be essential in determining whether the proposed mitigation strategy can be successful implemented into practice? These are my references for the graphs and the pictures I've used. Thank you for listening to our presentation.